Alright, tonight we're going to go ahead and do things a little out of order. What I originally thought we would do, I don't want us to be like over Thanksgiving break forgetting. So I'm going to actually teach things out of order, and we're going to talk about section 8.3, which is called matrix operations. So in this you're going to learn how to add, subtract, scale, or multiply, and hopefully we'll get to multiplying. Alright, so first let's talk about what a matrix is. Okay, so a matrix is going to be this box with those little braces around it. And let's say that A is defined as 3, 2, 0, -4, -5, and -1/5. Okay, so these are his rows, this are columns. Okay, so we're going to ask for two things. We're going to ask for its order. So the order of a matrix is defined as rows by columns. Okay? So its order is the number of rows by the number of columns. And now each one we can identify. So like if I said I wanted element 23, okay, it would be row 2, element 3. Okay, so this would be A, row I, column J. So for example, let's say the one that I've just given you, what's his order? Let's go ahead and call this example 1 complete. Alright, so the order again is rows by columns. So I have 2 rows, 3 columns. So it's a 2 by 3 matrix. Okay? If I ask you to identify A23, I want row 2, number 3, it would be element -1/5. Likewise, if I want A12, row 1, column 2 would be 2. Alright, so hopefully that makes sense. Alright, next we're going to go ahead and try to add and subtract matrices. Alright, so the first one I want to do, I'm going to have 0, 5, 3, -2, 6, -8. And I want to add to it -2, 7, 3, -9, 5, and 6. So first of all, I want you on every problem you do to give me the order. So this rows by columns. So this is a 2 by 3 plus a 2 by 3. That way you're just used to doing naming the order, because that is something we always forget about. Alright, so literally I add this one with this one. So 0 plus -2 is -2. 5 plus 3. You know what, let's just go ahead and write it. So 0 plus -2, 5 plus 3, 3 plus 5, -2 plus 7, 6 plus -9, -8 plus 6. Now, you don't have to show me all of that. I'm doing it for the first couple just so you can see it. So I get -2, 8, 8, 5, -3, -2. Alrighty? So again, don't feel like you have to write this. I'm going to write it for the first couple of examples just so you can get used to it. If you don't think you need to write it, don't write it. Alright, let's try a second operation. Let's say I want you to do -6, 7, 2, -3. And this time I want you to subtract -5, 6, 0, and -4. And I'm going to walk you through. So, what is the order of this one? It's a 2 by 2. This is also a 2 by 2. Keep in mind we are subtracting. So I have -6 minus a -5. 7 minus 6. 2 minus 0. -3 minus a -4. So my final answer is going to be -1, 1, 2, 1. Okay? Let's do a little bit of multiplication. And I'm just going to go ahead and keep this all as one example. So let's say A is defined as -1, 3, 4, 0. And let's let B be defined as 2, 5, -3, -6. I want you to first do -5B. And then I'm going to have you do 2A plus 2B. Alright, so -5 times B. So I'm taking -5 and I'm multiplying it by this, and what's the order of this? He's a 2 by 2. Which means I'm going to take 5 and I'm going to multiply it by every term. So it would be 5 times 2, 5 times -3, 5 times 5, 5 times -6, which gives me 10, -15, 25, -30. Alrighty, again, please you don't have to show that. I can't stress that enough. I'd really be, happy as pig and pie if you didn't. Alright, let's do 2 times A plus 2 times B. So 2 times -1, 3, 4, 0 plus 2, 5, -3, -6. So this time I'm going to try to get you to the point where we don't have to show every part, especially with the scalar. Alright, so it's 2 times every term. 2 times -1, -2. 2 times 4, 8. 2 times 3, 6. 2 times 0, 0. Do it again. 2 times 2, 4. 2 times -3, -6. 2 times 5, 10. 2 times -6, -12. I'm not done yet. Now they want me to go ahead and add. If you need to, you can just go ahead and do. So this, 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 and this. Alright, I'm going to try to do it without showing all my work. So I'm going to do row 1, column 1, row 1, column 1. -2 plus 4 is 2. Move to the second column. 8 plus -6, 2. Row 2, column 1. 6 and 10, 16. 0 and -12, -12. Alright, that's called scalar multiplication. Alright, next example. Alright, solve for x in the matrix equation. So I have 2x plus a is equal to b, where a is equal to 1, 0, negative 5, 2, and b is equal to negative 6, 9, 5, and 1. Alright, so the first thing I want you to do is we want to go ahead and solve for x. Okay, so let's not worry about our matrices yet. Let's just first solve for x. So do you agree you have 2x plus a is equal to b? If you want to get x by itself, we first have to get rid of a. So I'm going to do 2x is equal to b minus a. So I just moved a to the other side. Now I need to get rid of 2, so I'm going to divide by 2. Now, careful, because that's what you would normally do. Do you agree that's the same as multiplying by a half? I understand that that's not necessarily what you would love to do, but in matrices you can't divide. So it's really 1/2 b minus a. Now the matrices are going to come into play. So I'm going to go ahead and take 1/2 of b minus a. So the first thing I'm going to do is just take 1/2 of b minus a. So I'm going to start with b and subtract a. So it's going to be negative 6 minus 1. This minus this. 5 minus a negative 5. 9 minus 0. 1 minus 2. Okay, let's go ahead and clean that up first. So just leave the 1/2 out there. I get negative 7, 10, 9, negative 1. Now I'm ready to do the multiplication of a half. And remember, this is x is equal to this. 1/2 of 7 is 7/2. 1/2 of 10 is 5. 1/2 of 9, 9/2. 1/2 of 1, negative 1/2. And so that's how you solve a matrix equation. Alright, last thing we're going to attempt is multiplying matrices. Alrighty? Alright, so first we have a rule. Sometimes you can multiply matrices, sometimes you cannot. Okay? So sometimes you're not going to be able to get anywhere. What you're going to do to decide if you can multiply them or not is you're going to actually look at the orders of the two matrices you're trying to multiply. So let's say matrix A is just an m by n. And matrix B is, let's say, an n by p. The first thing you must look at, these must be equal. If they are not, you can't multiply. And this m times p is the order of the new matrix. Now for this, sometimes having little handy-dandy note cards is going to be a huge help. So I'm going to reach in my drawer and see if I can get a couple of note cards here. Alright. So let's say that I am going to try to multiply. I think we're up to example 4. Let's let A. I want AB. I don't know why I put a 1 up there. Alright, so I want you to multiply A times B. Alright, So the first thing I want to do is figure out if I can multiply A times B. So what are the dimensions of A? A 2 by 2, and the dimensions of B is a 2 by 2. So the first thing I do is check these inners. Do they match? Yes. So then I can multiply, and I'm going to get what's left, a 2 by 2. Now, when you multiply, you do row 1 times row 1. So it's going to be easier if I just show you. So 2, 4, 3, 7 times 0. Card hanging around. What I'm going to have you do is go ahead and cut it in little strips. Alright? And I'm going to want you to have several strips. So we're going to focus on row 1 and row 1. Alright, so when you multiply, you're going to multiply row 1 with column 1. So I'm going to do 2 times 0 plus 3 times 5. So you multiply row 1, column 1 plus row 1, column, right, row 1, this by this. Now I'm ready to come here, which is row 1, column 2. So here's row 1, move this over, I want column 2. So I do it again, 2 times 1 plus 3 times 6. Now I'm on row 2, column 1. So row 2, column 1, do it again. 4 times 0 plus 7 times 5. Here I'm at row 2, column 2. Row 2, column 2. 4 times 1 plus 7 times 6. Now I clean it up. So 0 plus 15, 2 plus 18, 0 plus 35, 4 plus 42. And when all is said and done, I get 15, 20, 35, 46. Alrighty? And that's how you multiply matrices. So let's try to do one more, and we'll pick these up in class tomorrow. Once you get the hang of it, it's not going to be bad. So let's say that I have matrix A is 1, 2, 3, and matrix B is 4, 5, 6. So the first thing I want you to do is AB. Then I'm going to want you to do BA. Alright, so I'm going to make you do it forwards and then backwards. So let's first write down what he is. So it's rows by column. So he is a 1 by 3. This guy is a 3 by 1. So can I multiply it? Yep, those work, and I'm left with a 1 by 1. So I'm just going to have one answer. So I'm going to multiply 1 times 4 plus 2 times 5 plus 3 times 6. So that gives me 4 plus 10 plus 18, which is 32, if I did my math right. Alright, so let's end by trying to do B times A. First, let's make sure it'll work. So B is a 3 by 1. A is a 1 by 3. Are those the same? Yes. So I'm going to be able to multiply, and I'm going to end up with a 3 by 3. Okay. Ready to go. Let me see where I put my little cards. Who knows where they went. Oh, there they are. So I want row 1, column 1. And then I'm going to do row 1, column 2. Alright? So, and you know what? I'm going from here to here. So row 1, column 1. So 1 times 4 is 4. I'm going to unzoom so you guys can see what I'm doing. Alright, now I'm at row 1, column 2. So 4 times 2 is 8. Row 1, column 3. 4 times 3 is 12. I'm back to row 1. This time, though, I'm column 2. So I'm in row 2, column 1. 5. 5 times 2 is 10. 5 times 3 is 15. Alright, last one. 6 times 1, 6 times 2, 6 times 3. And that's my final answer. Alright, so I went over by just a little bit, but I will see you guys tomorrow.